everyone. Today we'll be discussing about the concept of random access. Random access, it's nothing but the process when the information is being accessed at that time, at what interval the information is being accessed, if any chances are there of like not receiving the information properly because of some errors in the network. So this methods, there are two types of methods which are being considered in the random access. The two types is, one is said to be your slotted aloha and pure aloha. Okay, main important thing is that pure aloha is nothing but without any adjustment you are said to be doing some changes and you are said to be sending and receiving the information in that particular time only. That is said to be your like pure aloha. Without any adjustment your information is being passed. Only thing is that it will check for the collisions within the information. That is said to be your concept of random access. Random access, it will rectify the collisions which are being happening when the data is transferred from source to destination. Okay, so the destination, it doesn't mean that one person to person, it is the information transferred from one device to another device. In between multiple devices may be there, so those devices, how do they like communicate with each other before the collision happens, that is being covered in this random access. Okay, so let's check. In the random access, as I said, there are two types. One is the slotted aloha and the pure aloha. Pure aloha and the aloha concept is the same. Okay, since your aloha concept, it belongs to a LAN part, it is said to be covering, it's a wireless communication where it is between a campus, you can say within the particular campus only the information is being transferred. Okay, so here main thing is that the information may be transferred from one source to another destination. That happens, you can see, from one station to another station, from one device to another device, the data is being transmitted. Okay, at that time when more than one frames are transmitted at a time, when more than one frames are being transmitted at a time, there are chances of colliding. Colliding is nothing but, okay, when I transfer multiple frames at a time, there are chances that one may be moving slower, one may be faster, one may be slower, one may be faster. So at that time there are chances of colliding with each other. When the collision happens, there are chances of not receival of that particular information to the other end. At that time there should be maintained with certain concept that if an acknowledgement is being not received when the collision happens, at that time there are chances like a back off period is being considered. A back off period which is being considered when the information is being transferred as back off period is the time. In that particular time, okay, if I see some problem is there in between, the chances of collision is there, one data may collide with each other, I may take a back step. The data may take a back step and may execute late. So back off is such that it shouldn't be too much, so it will collide with many other frames also. Back off maybe 1 second or 2 seconds, so that the others also take a back off for certain amount of time and the information gets retransmitted. That is the concept of aloha. Aloha, it will be a process in which it will rectify the collision and it takes a back off in that particular duration. Okay, you will be using various terms in this aloha concept. Those terms let's check out. Okay, so in the aloha model you have a x frame, x number of frames may be there. Okay, and you have a s is nothing but the successful transmission of the information in that particular seconds. Okay, that is being considered. Successful transmission of information being transferred from one end to another end without colliding is the S part. Okay, X is the frames which are being sent in that particular time, and G is your load, the load which is being carried by the whole transmission line. Okay, when it is being transmitting, it may be transferring n number of frames at a time. So those n number of frames load is nothing but your G, and P success is nothing but the probability of success of reaching the information to the other end. Nothing but transmission of the frame to the other end successfully is your P success. So your S the throughput or the output is nothing but GP. Is nothing but it's the load plus the success in which the information is being transferred to the other end without any disturbances, without any collision. It is said to be reaching to the other end. That is said to be your concept of your probability of success. S is nothing but it is consisting of both G and P, load plus the probability chances of frame being transmitted. Okay, so this is aloha concept. In this aloha concept you have a probability which is being called as your Abraham's assumption. There may be an assumptions that I may check out with the assumption, okay, what is the vulnerable period in which it may take a back off. Okay, that also has to be considered when your frame has to be reaching to the other end in a successful way. When that you have the load which is being considered, okay, in that particular seconds, how many arrivals are being there. Okay, maybe 10 arrivals, 20 arrivals in 20 seconds, like that it is, and that is being considered. Your particular frames into n intervals is being considered. So your frames divided by n number of peoples or n number of intervals are being considered. N number of frames in that particular seconds, that is x, is being considered. And the probability, it's nothing but the probability in which the frames are being transmitted to the other end without any problem, as we had discussed. So G is equal to NP. It will become N is number of intervals, okay, and P is your probability of success of arrival of your data or frames, okay, that it is being considered. And here, since there are n number of intervals and n number of x number of seconds, so the P success, probability success, it will be dependent on your number of seconds and number of intervals, you can say. Okay, so you have 1 minus P probability whole 2 to the power n. It is nothing but 1 minus the load divided by the n number of probabilities which are reaching successfully with transmission to the other end with the frame. So you can say it as e to the power minus 2g, where n is infinity. Okay, you can't say how many people are, how many frames are being arrived in the network. So it is infinity. Okay, so it is e to the power minus 2g exponential to the load which is being considered. So here throughput of the aloha is being considered as S is equal to GP, where G and P is nothing but e to the power minus 2g, which is being considered. Okay, so this is the important one concept in the aloha, that you should know the load, the probability, n number of intervals and n number of seconds which are being considered for traveling of information from source to destination in particular seconds. And this is the aloha formula which is being considered for successful transmission of information from one end to another end. Nothing but your higher way of information transferred from one end to another end, from one point to another point. It will be calculating the throughput in which number of seconds the load is being considered and how much load is being transferred to the other end without any disturbance. That it will be considered. Okay, so this is the concept of aloha which you have learned today, which is the basic concept, a basic question in all the question papers. Okay, so you remember what is aloha? Aloha is within the LAN and it will be considering the number of frames, number of probabilities of chances of reaching of frames to the destination. Okay, so that is the concept of aloha which is being considered in the network aspect, in the MAC aspect. Okay. Thank you. I will be discussing tomorrow about the slotted aloha concept. Okay. Thank you.